So last week we went over how to use economic factors such as days on market into a dashboard to get really awesome analytics and insights from it. Today I'm going to show you how that was actually produced using Python inside Databricks. So you'll be able to actually do this on your own if you like. You'll be able to understand how the data was transformed, how the graphs were created, and some of the statistics that go behind it. So I'm going to be breaking this down into two parts. First part is going to be going over the data and some of the initial charts. Second end is going to be going over some of the statistics and the ladder charts, as well as future use cases. My name is Ariel Herrera with the AnalyticsAriel channel, where we bridge the gap between real estate and technology. Please like this video so that YouTube can share this with others and have it in their system. As well, please subscribe because we have a lot of great analytical content with code walkthroughs upcoming in the next several weeks. So average days on market, what is that? In case you haven't watched a previous video, which I highly suggest you do, days on market is essentially how long a house stays on the market before it's sold. So for example, if I have a home that I put up for sale at the very beginning of the year, January 1st, and it sells at the end of March, it's been on the market for 90 days. And why is this important? Because it could be an indicator for us for a local town or for a county or even for a city. How the days of market is trending could signal growth or decline. How do we get this data? So the way I'm doing this is using Zillow. Zillow is a website that aggregates data from the MLS and actually has information such as rentals, sales, and more. So publicly available, they do have the availability to get days on Zillow, which is very similar to days on market, and information specific to the metro, state, county, and city. So in this case, I'm taking county and I'm also taking city, downloading these in order to get a deeper insight as to what data we can use to analyze days on market. So right now, you're seeing days on Zillow by city. So we have information such as the size, the region, so how big is this region, the region name, New York City being number one, no surprise there, the region type, state name, which is interesting, something that we would want to look at further. And then we have each column a specific year and a month, starting from 2010, January, all the way down, in this case, to January of 2020. So this is some data that we're going to use. So on top of city, we're also looking at county. And county, I believe I have back here. I do. Again, similar information, the size, the region, county, state name, months. However, there is an issue here where we're not actually able to map back what cities are in which counties. So to look at that, I actually go to Google. Google has an API. An API is a way to retrieve public data source. You need a key in order to do so. And in this case, Google, if you provide an address or something that looks like an address, for example, I believe this might be one of their headquarters, and you'll get as a response the latitude and longitude as well as other information and coming back in a JSON format. And here's the latitude and longitude that we want in order to plot our counties and cities later on. As well, we also want to be able to get per county what the state is and the city, and so we can merge this data set together. So going back to the notebook here, and I have the resources, so I'll have that in the show notes. You can always go back to those websites that I just referred to. So in Databricks, it's going to be different based on the environment you're using, but the way I uploaded the data was by clicking data and then add data. Very simple. It can also be done through a command line interface as well, or if you're using Jupyter Notebooks, you could just have it in a folder and reference it. So because I'm doing a dashboard, I have widgets for the user to select. That way it updates automatically, which I find to be a really awesome tool, something that users love. At the beginning, I like to remove all the widgets. That way, if there was a lot of fumbling around with them, it just resets it to the beginning. Next, I have imports. These are the libraries I'm using. I have some general ones for time, ones for manipulating data. My favorite is pandas. Visualization, which my favorite is PlotLi. Love PlotLi. I'll go through that. And then how to actually get that API request from Google, which is using request. I'll go over some of the functions in just a bit. But first, the step I'm doing is loading in my data. So as I said previously, I have that county data. I put it into that file store table, which was in this area over here. And now when I display this DataFrame is like a table, you can see the same thing in Excel, but now in this display. I still have my size, my region, the type, the state, as well as the months. However, this format isn't really that usable, having each of the months listed as a column, so I'm going to reformat that in a bit. But first, I want to be able to give the user a dynamic way to select state. So if I want to supply a widget, I had to give it a list of values, right? And I could, if I wanted to, I could actually manually type in each single state in the United States. But is that efficient? No. So what I'm doing is I'm going to my DataFrame DF County. I'm sorting by the state name so that I can get the states in order. Alabama would come first, and then last would be Wyoming. Making sure that I'm only getting unique values, and then I'm putting them to a list. That way, dynamically, the user or this widget is populated with the state information. And then I want it to be defaulted on New Jersey because it is the best state in the country and the one I reside in. Next, what I'm doing is I'm grabbing that widget, that value. That way, if the user changes this to, say, Florida, it now has updated the variable. And when this is changed, I want to update my main data frame, which I just label as DF. So what I'm doing is I'm using pandas to actually locate where the state name equals that of the widget, in this case New Jersey, and set that as my data frame. And as you can see here, now I'm only looking at counties that are from New Jersey. The next thing I'm doing is I'm loading in my APIs in order to be able to get responses for information. So the first one, Google, I had already showed you. And then PlotLi, I'm going to be doing a scatter plot later, which I'll show you right now what that looks like. So scatter plot map box. This is in order to plot geography. And you do need a token in order to do so. They tell you how to get access to that up here, Mapbox access token, if you want to do that on your own. And it's very sensitive, a security issue for API keys, so that's why I don't have it listed here. I'm actually taking it from a CSV file, locating it, and setting it as my variables. So the next thing I'm doing is I'm also loading in my cities. So these are more specific within each of the counties. And then what I'm doing is loading that into a display form. You can see again I have the size, the region, the name, city, and state. Next step is doing a little bit of exploration. So I want to set up my next widgets, which is the start date and end date. And again, I want it to be dynamic. So in this case, I'm actually referring back to my data frame right here. And I want to have my year, the list of all the years available based upon my data frame. So that's why I'm doing this. Because of the way this data frame is laid out, the columns with the months don't start until after 1, 2, 3, 4, 5, which is why I'm doing grab after 5, all of the columns, which should only be month columns, which they are. Then I want to extract the year, so that's what I'm doing here. I'm labeling month columns for each of the months in the column split by that dash. As you can see, there's a dash right here. And then grab that first element, which should be the first element 2010. And that way I'm getting the year. I'm sorting that, and then I am putting that as a widget a little bit further down over here. Over here, I'm actually adding it as a widget, and then I'm selecting the first one to be the default, which should be 2010, and then my end date, the very last one, which should be the most recent. In this case, I have 2019 of December. And then for my trend years, which I'll explain later on, I'm comparing days on market from one year to the next. I want to have the most recent years, so that's why I'm looking at 2018 to 2019. I have this table that I need it to be updated every time someone changes the state, start date, or end date. So this is why up here I'm getting the widgets. And I'm going to be doing this frequently. Now, I did tell you beforehand, the way that this is formatted, the data frame, isn't that useful because the months are in columns. So what I'm doing here is using pandas, PD, I'm melting the data frame. And I'm also selecting only the dates that are relevant to us based upon the widgets. And as you can see now, those columns have now become melted so that they are in one single column versus being, one single column versus being across many columns, which makes it a lot easier for us to do data transformations on. And then I'm adding 2 more columns, year and month, so that I can actually filter on those as well. Next, what I'm doing is I want to be able to plot the data using the actual month name versus the integer of it, because that isn't really that friendly to the eye. So using the library DateTime, what I'm doing is for every month that I have, every month number, I'm just calling it X, it should represent the month. So turn that into a time, then turn it back to a string, and only get the abbreviated month, which is what we see here, January through May. I'm just only looking at the top 5 here, just because I'm printing it out. And now that we have that information, we can actually look to, one, get a table here, and then also plot it later on. Just going to close this for now. So that DF melt table, that one that we had up here, I want to be able to see what this days on market looks like across all the information that we have for each month, regardless of the year or not. Just want to see what the median is. So I do a group by on the month, which is right here on the left-hand side. And then I'm selecting days on market, and I want to get the median of it. And I want it to look like a data frame, so I'm resetting the index, and this is what we get here. So what's awesome with Databricks is if you want to add this to a dashboard, you just click up here. And in this case, I already have a dashboard going. So if I go look at that dashboard, and I click here, we're going to see that table available. And what is really neat is that I can just drag and drop this table around. I could also expand it. If I had more rows, maybe I want to expand it. Or also could make it smaller if I'd like. And what's really powerful about this is that for other tools such as PlotLi Dash or RShiny in order to create dashboards, they're more specific on the placement, whereas here if we're doing prototypes, you don't really care about the placement. You just want to get it there right away. And that's why Databricks dashboard is very powerful with that. Tableau is the same thing, except it has a little bit less control on the programmer end. So now I have my table in there, and then again I'm getting my widgets because I want this to update every time, and here I'm actually creating my chart. So again, a little bit funky with the dates is that the way I want it to look like for the title is I want it to be dynamic, where I have the state that the user's selected, and I want it to be updated for the start date and end date as well. So what I'm doing here is I have my widgets, the start date and end date, and then again I'm putting it into a time format and then putting it back into string based on how I want it to look like. So I don't want it to look like 2010-01. Now, for those who aren't familiar with the DateTime Library, I'm just going to go to it quickly. I reference this all the time. So I'll put this in the show notes as well. And if you go all the way down to Python's documentation, you could actually see that percentage and text character that I'm putting is basically giving us a label back for a certain timestamp or date time. So in this case, if I would have put percentage A, I would have gotten back the day of the week truncated by 3 characters. So Sunday, Monday, Sat, like that. And if I want it to be the full name, then I would use capital A and so on. So that's where I'm referencing that directive. So when I go back here, I want to create that box and whiskers plot because I want the user to be able to kind of gauge not just one single line chart, because that's a little bit misleading. I want them to understand from month to month what are some of the outliers that exist, like the high days on market for each of the counties, the lows, and then what the median looks like. So if I go over to PlotLi box plot, I love PlotLi, and the reason being is if you just want to create a box plot really quickly, you could do so with one line of code. What this is doing is literally selecting the box plot, entering your data frame, and then specifying what column in your data frame you want to plot. So easy. And then what's really cool is all the interactivity that goes on with it. You could even get closer or back up. So what I'm doing here is my melt data frame. I'm selecting that as my data frame. I want to plot on the x-axis the month, which is down here, January to December. On my y-axis, I want to do days on market, which is going to be vertical. And then my title, I want it to be dynamic. So this curly bracket with 0, 1, and then 2, what that signals is this is my string, and I want it to be updated with these variables dynamically. That way, again, if the user changes the state, the start date, the end date, this is going to automatically update this title. Just really awesome. And then the layout, I'm also defining what ticks I want available, because initially it was actually skipping around some of the months. So I want each of these months to be represented and the name for it. Then I do show, and this comes up. Again, when I want to put this into the dashboard, I just click up here, put it in the dashboard, and then I can move it around. So initially, I think it was a little bit smaller, this dashboard, and then I enlarged it, and that's how you could see all the months across, which is great. And the next step is moving on to days on market by county. How are we getting this data? Because this is cool. We're aggregating information across 10 years in different counties, but now I want to get a little bit more specific on how certain counties look like in comparison to their peers. So what I'm doing here is that DF melt data frame. I'm only selecting the size and the region in order for me to focus on only a couple of counties because there's a lot here. And I only want to look at the top 5 based on size. So again, selecting those columns, dropping any duplicates, which of course would occur if we're looking at several years and months. We're going to see Bergen County come up several times as in our table as records. So we're dropping that, and then we're sorting by the size in order to get the top counties by largest size first. And I label this data frame by size, very simple. Now I go down, this is where I'm creating the line chart. So again, grabbing my widgets to automatically update, and what I just showed you before, sorting by the size rank. I could have set that other one to data frame I could have actually just selected this and inputted it in here, which I'm actually going to do because that way my code isn't repeated. So here, and then head. Head is selecting from the top of the data frame the first 5 rows. If I wanted to make it the first 10 rows, I could put 10 in there. This is automatically going to be the first 5 largest counties. So next what I'm doing is getting the size of the region to a list, and then I'm selecting my top 5 regions and putting this into a plot. So I have my data frame of my top 5 regions because I had selected over here that the region name must be in the top 5. Then I'm selecting on my x-axis, I want the date range, which in this case is year to year, days on market on my y-axis, and then color. Color is how this data is split. So if I didn't have color, this again would do an aggregation similar to this chart, where it's just all the counties mixed in one. And I don't want that. I want it to be split by the counties. So using color, I'm able to do that. And then for hover name, when I hover over, I want to see the county right up top. So you can see here, Monmouth County right up top. And then by title, because I don't need this to be dynamic, I could, but I'm just setting this as top 5 size, days on market. So I'm not doing any of that previous formatting that you saw in the other chart. And then template, I'm setting that to white. PlotLi has different templates. I love the black templates. They're really cool, and I feel like they're more easy to read by the eye. So you could definitely play around with that. And now this chart is created. Again, dynamic. I can select, get a little closer at certain periods of this chart. This is definitely a better deep dive. I could unselect certain counties and then look at how that trend is. So really powerful stuff here. So that concludes part 1 of the technical deep dive. In the second half, we're going to go over the other charts where we're actually assessing the change year over year and then specifically looking at a county. This goes to a little bit more statistics and also into plotting latitude and longitude, which is awesome. So please like this video, subscribe so that you can stay tuned and get the latest notifications for our new videos. Thanks so much.